Hello. Here in this segment today, we're going to continue with section 8.3, applying equations, and we're going to take a look at some more examples and skill check problems so that you could have a little bit of extra practice and hopefully additional help as you continue with the homework here. Okay, so let's first of all take a look at some of these statements. I think this was from the last lesson already. If x is an even integer, how can we represent each of these followings? Well, if we just simply state x is an even integer, then we can say the next integer is x plus 1. But then if we want to find the next even integer, that's 2 away from this even integer, isn't it? So then that's going to be x plus 2. So we have x is one even integer. If we want to find the next even integer, that's going to be x plus 2. Now, let's take a look at this skill check right here. Okay, here we have a statement. The sum of 2 times a number and 3 is half the number. So here, we're going to take this statement and we need to rewrite it as an equation and then solve. So the sum of 2 times a number and 3. Okay, remember our is the equal sign, right? The sum of 2 times a number and 3, okay? The sum. We're going to be adding some things together. What are we adding? 2 times a number, that's 2x, and 3. So 2x plus 3, that's our sum right here. This is your equals half the number. Okay, so half the number, our number is x, right? Half of that is just 1/2 times x. And then so when you could do this several ways. Okay, you can next subtract 3 to this side. And then the 1/2 x, subtract this also and bring it back over here. And then you're going to end up with 2x minus 1/2 x is equal to -3. And you can multiply by 2 to eliminate the fraction. Or you can have 2 minus 1/2. That gives us 1.5. Okay, and then you have 1.5x, and then you bring the 3 over to the other side, and then you'll have -3. So anyway, when you solve for x, okay, you have your x's on one side, your -3 on the other side. When you solve for x, you're going to end up with -2. Now, another way you could do this is if you want to eliminate the fraction right away, just multiply everything by 2. Then you end up with 4x plus 6 equals x. And then you can bring your 4x over to this side, and then you'll end up with -3x. And then on this side, you have 6. And then 6 divided by 3, -3, is going to give us -2. Okay, so there are several different ways that you can derive to this answer right here. For our next example, it says 5 times the sum of a number and 3 is 6 less than twice the number. So remember, identify your is, that's our equal sign, right? And then we've got 2 phrases here. And so we could take this first phrase and rewrite this, and then take this phrase and rewrite this into mathematical expressions. And we have 5 times the sum of a number and 3. So the sum of a number and 3, that's n plus 3. And then 5 times that, okay? And then is, or equals, 6 less than twice the number. So we could do twice the number first, that's going to be 2n. and it's 6 less than that, minus 6. And then here you would distribute your 5, right? 5 times n, and then 5 times 3, so you have 5n plus 15 now equals 2n minus 6, and you can simplify that, and you'll end up getting n equals negative 7. Now, we're going to take a look at some examples that talk about finding consecutive integers, or consecutive odd integers, or consecutive even integers. Consecutive means 2 in a row, okay? So here it says 2 consecutive integers. For example, 2 consecutive integers would be 14 and 15. 29 and 30. Those are numbers that follow each other in our number system, number line. Okay, so, but if we now here we want to find 2 consecutive integers whose sum is 91. So we have to define our variable, okay, x. X is equal to the first integer. X plus 1 is equal to the next integer, or the second integer. Now, their sum, okay, so that means the first integer plus the second integer is 91. How do we write that? You have x plus 1, okay? This is the sum of these two numbers, is or equals 91. So when you solve for this, you have 2x plus 1, or if you subtract 1 to the other side, then you have 2x equals 90. And here x, you simplify that, x is 45. Then x plus 1, okay, 45 plus 1, that's going to give me 46. So you can go back and check 45 plus 46 is definitely equal to 91. And that gives us our 2 consecutive integers. Okay, here, now we have 2 consecutive even integers. Okay, so if they're both even, the first one, we can say x is the first integer. Then the next even integer is going to be 2 more than x, right? So that's going to be x plus 2. And then their sum, okay, so that means x plus 2 is 94. Is the equal sign, right? Now when you simplify this, this is 2x plus 2 equals 94. If I subtract the 2, I get 92. 2x plus 2 equals, or 2x equals 92. And then divide by 2, my x is 46. That's the first integer. The second integer, I add 2 to that, so 46 plus 2, and then I get 48. So my two numbers are 46 and 48, and when you add those two together, they are equal to 94. 46 plus 48 equals 94. Okay, now we're going to take our number of consecutive integers and we're going to expand that even more. One more. We're going to have 3 consecutive integers, but this time they're going to be odd integers, such that twice the first is 7 more than the third. So our 3 consecutive odd integers, x is the first odd, oops, sorry, this should say odd. Okay, x is our first odd integer, x plus 2 is the next odd integer, and x plus 4 now is going to be the third odd integer. So twice the first, that means 2 times x, is or equals 7 more than the third. So what's our third integer? The third integer is x plus 4. Well, here, this is 7 more than that. So then that's x plus 4, right here, plus 7 more. And when you simplify this, and then you'll find that our x is equal to 11. X plus 2 then is equal to 13. And then x plus 4 is equal to 15. And then our three odd integers are 11, 13, and 15.